Okay, so now that we have seen with Greg Jones that there are basically two things I take home. It's what about water distribution and what about the occurrence of extreme climatic events. So today we are going to review quickly the consequences of having had a wet year in 2017 vintage, but we are also going to put an emphasis on what it means that heat spells are causing in terms of plant physiological development and fruit composition. So throughout the day, I'm going to moderate different speakers, trying to illustrate what has the biggest footprint. Is it the very important winter rain? Is it the duration of each event? Is it their frequency? And apart from that, we will also discuss what is to expect from the fire. But in order to really give some sort of coherence to the talk, we are going to slice the season into 5 different periods. Those 5 different periods actually are looking closely at the key stages of the plant's development that are going to have an effect at shaping the fruit quality. So if we look at a season going from your left to your right, the period 1, the blue one, is everything that happens while the vine is dormant, from leaf fall to bud burst. The period 2 is the period where there is this explosion of leaf area growth. Within period 2 you have bloom, and period 2 ends more or less when the maximum shoot elongation speed has been reached, the maximum shoot length is there. And then we enter into period 3, which hopefully kicks in before veraison. And during period 3, you have some leftover in terms of nitrogen uptake, in terms of canopy establishment, and also environmental stresses are going to have carryover effect at boosting color, at boosting secondary metabolism or primary metabolism at the berry level. So we'll discuss that. Then at the transition between 3 and 4 is veraison. And then while fruit is maturing over period 4 and 5, we wanted to introduce a more subtle division which marks the transition from period 4, during which sugar accumulates, during which most of what size the berry in terms of volume, concentration in sugar is defined, from the period 5, which lasts a bit more and which marks the transition towards the polishing of secondary metabolites such as total anthocyanins, but also different tannin polymerization. So we'll discuss also how the climate is affecting the transition from 4 to 5. The first talk today will look mainly at how the climate will affect stage 1, 2, 3, and 4. And for that, with Elizabeth, we will basically see how heat and climate in general is affecting the onset of bud burst, bloom, or even veraison. Then for the physiological assessment of the season, we will look really much at how period 2 and period 3 set the stages for fruit composition during period 4 and 5. And for that, we will look at some plant indexes. And then, to end the overview of the vintage, we are going to have Nicola and Federico really looking at what shapes stage 4, what shapes stage 5, and how can we get some insider knowledge to improve from the history of the fruit composition the way we handle the fruit in the cellar. But now let's just look at period 1 as an introduction to the first talk. From leaf fall to bud burst, we basically can look at how much water fell and how much temperature got accumulated. So here, instead of showing the historical weather station of Simis or some ambassador representing Stag's Leap or Montvideur, what we've done has been to do overall statistical analysis pulling more than 200 weather data that are all distributed within Napa Valley and run statistics on them over multiple years so that we get a better picture of not only what is the mean temperature coming from all the weather station networks we have in Napa, but also what are the extremes, either the lowest or the highest in terms of water input or in terms of heat accumulation. So here, if we look in green at the mean, you see that, yes, for sure, 2017 has been a high water supply during the winter, but you see that 95 and 98 were not so far off. And interestingly, you see that there is a wide scattering of maximal amount of winter rain going from 800 millimeter on average up to 1200 millimeter, which is really then looking at the most extreme amount of water we got. What I want to point out here with this slide is that based upon the location of your vineyard, you may be in a year that's wet, or you may be in a year that's extremely wet that you've never seen before. And you will see that's going to be a recurring pattern. As the warming of the climate is observed, we boost the contrast between climatic situations for each different vineyards. Looking at thermal time, again during the winter, what is interesting is that we basically have something that is fairly similar to the winter heat accumulation pattern observed in 12 and 13, whether we look at the most extreme in orange or at the average. What kind of consequences will that have at initiating the onset of bud burst and then scheduling the onset of bloom? That's something that hopefully we'll discuss with Elizabeth very soon. But at this point, the first take-home I'd like to get from looking at the period 1 is that it was the wettest year we had and similar in terms of area distribution to 95 and 98. Like 2011, we started the bud burst and the initiation of grain growth with root reservoirs that were at their fullest. So no fear of growth rate being negatively affected by early water deficit. And the heat accumulation profile is relatively mild during the winter. So the 4 questions that we are going to try to solve during this talk are going to be, what does that mean in terms of initiating the next phenological stages? And in terms of plants, what does it mean in terms of enhancing the growth rate, enhancing the nutrient uptake rate, or setting up the total transpiring leaf area size, what we call the basal crop coefficient. So we're going to discuss that, but before that, my pleasure is to invite Elizabeth Volkovich to share with us what is going to be the expected consequences of contrasted climatic conditions as setting the phenological response of the plant.